Hello and welcome everybody. My name's Noah Deere and we are going to do the Now You Try problems for solving equations in function notation. So this next problem, which I just fixed the numbering, the first problem, number 1. Let f of t equal 5t minus 7, and we want to solve the following equations. Keep in mind that full explanation for this is given in the previous video with the examples. Here I'm just walking through the solutions really quickly. So what we do is we set up 5t minus 7 equals negative 6. Add the 7 to both sides. Get 5t, not 7, equals 1. Divide by 5, get t equals 1/5, and write the solution set is the set containing the number 1/5. All right, part B, f of t equals 33. So we'll set up 5t minus 7 equals 33. So I'll get 5t equals, adding the 7 to the other side, we get a 40, and then I divide by 5 and get t equals 8. So the solution set is the set containing the number 8. Moving on to number 2. Let g of m equal negative 9 times, parentheses, 2m plus 1, close parentheses, minus 5. Solve the following equations. G of m equals negative 14. So I'll set up negative 9 times 2m plus 1, 2m plus 1 in parentheses, and then minus 5 equals negative 14. I'm going to do this by adding the 5 first, so that I get negative 9 times 2m plus 1 equals negative 9. Then I can divide the negative 9 on both sides to clear it off of the left side and have 2m plus 1 equals 1. I subtract the 1 off to get 2m equals 0, and then divide by 2 to get m equals 0. So we can write the solution set is the set containing the number 0. All right, 2b now. G of m equals 2/3. So we'll set up negative 9 times 2m plus 1 minus 5 equals 2/3. And let's do this one in the different strategy. Let's distribute that negative 9 across the parentheses first. So if we do that, we get negative 18m minus 9 minus 5 equals 2/3. Combine like terms, negative 18m minus 14 equals 2/3. All right, so now I'll add the 14 to both sides. And, well, I want to do a little bit of scratch work now. So if I have 2/3 plus 14 over 1, I need a common denominator, so times 3 top and bottom on that 14. This will give us 2/3 plus 14 times 3, that's 30. 10 times 3 is 30, 4 times 3 is 12. So 30 plus 12 is 42 over 3. So adding these up, 2/3 plus 42/3 is 44/3. And we'll definitely leave that as an improper fraction here. Bring that back over to the equation at hand. We have negative 18m equals 44 over 3. And then handy thing to do here is I'm going to multiply both sides by negative 1 over 18. And I'm doing that to clear out the negative 18 on the left side and be left with m. And do it without dividing. When I have a fraction involved at all, it's really nice to multiply by the reciprocal instead of dividing. It will get us to the same place, but this can just save us a little bit of a headache. So let's see. The 44 and the 18 can be reduced to a 22 and a 9 there. And so we'll get negative 22 over 3 times 9 on the bottom is 27. So I'll write the solution set is the set containing the number negative 22 over 27. So watch your fraction arithmetic there. Watch your arithmetic in general in these problems. This is challenging you on that arithmetic on purpose, trying to give you more experience and practice. I mean, let me say this. Everybody sees a problem with the fraction and goes, okay, this is going to be more of a struggle. There's going to be more steps involved here. This is going to be a little bit more work. Nobody denies that. But we want to get to a comfort level with it where it's not a huge struggle and something where we feel like we're going to end up making a mistake. We want to practice it until we feel like we can confidently do it without making mistakes, at least as often as we have in the past. Always looking for trying to become a little bit more proficient, a little bit more capable of remembering which steps I need to take at which point in order to do the fraction arithmetic and get through it cleanly. So just go slow. Remember that if we're adding fractions, we need a common denominator. If we're multiplying fractions, we do not, but we can reduce them before multiplying. So those two things right there are really helpful. All right, one more problem here. Number 3. Let f of x equal 3. This is saying that no matter what we input for x, the output will always be 3. That means for this first problem that we're trying to solve, f of x equals 5. Note the difference here. F of x equals 3 is the definition. F of x equals 5 is an equation we're trying to solve to find what input will output 5. But we've already defined f so that no matter what the input is, the output is always 3. So f of x equals 5 has no solutions. Right? No input will get us to an output of 5 because every input gets us to an output of 3. So you write that the solution set is the set containing nothing because there are no solutions. Part B says f of x equals negative 8.2. Solve that equation. What x value that we input will get us an output of negative 8.2. Again, that can never happen. We can only output the value of 3 for the function f. So we again write the solution set is the empty set. Finally, we look at the equation f of x equals 3, and here we know that that's the definition of the function. No matter what x is, the output will always be 3. So this equation, every input is a solution. Every x value will get us an output of 3. So all numbers are solutions to this. So we write the solution set is this capital R with the extra line through it. This is the set of all real numbers. And this is equivalent to saying all the numbers from negative infinity to positive infinity. So you can really write that in either form here. I guess if we're using the interval notation, we might say the interval of solutions. But really, either of these is fine. Intervals are sets inherently. Kind of a little nuance there. All right, that's everything. Thank you so much for watching, everybody. Go ahead and pause, rewind as you need. Make sure you've got this all sorted out. And then go ahead and move on to the next video where we will look at evaluating and solving functions given in table format. And then we'll do evaluate and solving functions given a set of points. And then we're going to do graphs after that. And then we'll be all done with this lesson. So just a few more things after this video. It might sound like a lot, but they're not too long. All right, thanks again, everyone. We will see you in the next one.